In number 3, we're being asked to get the derivative of 2x cosine x minus 2 sine x. And the first thing I see is that we're going to be able to use our sum and difference rule. This subtraction in the middle means we can just get the derivative of this piece and then subtract the derivative of this piece. But over here, things are a little bit more complicated. We don't just have a constant multiplier. We have a 2x and then a cosine x. I'm going to think of the 2x as my first piece and the cosine x as my second piece. So let me begin by using the product rule to get the derivative of 2x cosine x. I'll put the first 2x times the derivative of the second, and the derivative of cosine x is negative sine x, plus the second, which is cosine x, times the derivative of the first, and the derivative of 2x is 2. Then I can just subtract the derivative of this piece. So I'll subtract, and I have a constant multiplier of 2. I can just bring that along, and the derivative of sine x is cosine x. Allow me to highlight the addition and subtraction symbols. I'm thinking of this as a negative. Here we have an addition symbol. Here we have a subtraction symbol. This is one term, this is one term, and this is one term. I'm going to say 2x times negative sine x is negative 2x sine x. Of course, a positive times a negative is a negative, and 2x times sine x is 2x sine x. Then I'll add 2 times cosine x, which would be 2 cosine x. And finally, I'll subtract 2 times cosine x, which would also be 2 cosine x. Of course, my positive 2 cosine x will cancel out with my negative 2 cosine x. My derivative is negative 2x sine x. Looks like we got it right once again. There's really no alternative way to rewrite this equation, so here we're going to need to use the quotient rule. The derivative equals the bottom times the derivative of the top. So I put the bottom, and since it's a binomial, I safely enclosed it in parentheses, times the derivative of the top. The derivative of the top is 5, minus the top, and the top is also a binomial, so the top I'm going to put in parentheses. The top times the derivative of the bottom, and the derivative of the bottom is 2x. If my expression involves more than one term, it needs parentheses. The bottom is a binomial. The bottom times the derivative of the top, which is just a number, minus the top. Once again, I have a binomial. It needs to be in parentheses. Times the derivative of the bottom. The derivative of the bottom is simply one term. This is, of course, all over the bottom squared. Over here, I need to distribute this 5, which will give me 5x squared plus 5. Then I'm going to subtract what I get when I distribute this 2x. I'm going to subtract what I get when I distribute that 2x, so I better put what I get in parentheses. 2x times 5x is 10x squared, and of course 2x times negative 2 is negative 4x. So notice in the numerator I have a 5x squared and a negative 10x squared. That's negative 5x squared. When I distribute this negative, that gives me a positive 4x, and I have this positive 5. I think it looks good once again.
Let's look at one last example. Determine the equation of the line tangent to the graph of f of x at the point negative 1, 1. Well, I know to determine the equation of a line, I need a point and a slope. I have a point, all I need is a slope. And of course, to get the slope of this graph at the point negative 1, 1, I need the derivative. But before I attempt to differentiate this function, I'm going to rewrite it as one fraction without any negative exponents. I rewrote this 3 as 3 over 1, and now I can subtract these fractions using the McFarlane method for subtracting fractions. I know a fraction minus a fraction equals a fraction, and my new denominator is 1 times x, and my numerator is x times 3, or 3x, minus 1 times 1, or minus 1. Let me express this as a double-decker fraction. Now I just need to multiply the numerator times the reciprocal of the denominator. So I'll multiply it times 1 over x plus 5. Of course, 3x minus 1 times 1 is 3x minus 1. And x times x plus 5 is x squared plus 5x. Now I can get the derivative, and I'm going to need to use the quotient rule. I'll put the bottom, x squared plus 5x, times the derivative of the top, the derivative of the top is simply 3, minus the top, which is 3x minus 1, times the derivative of the bottom, which is 2x plus 5. And I'll put all of that over the bottom squared. So in the numerator, the first thing I can do is distribute this 3. That gives me 3x squared plus 15x. I then need to subtract, and I'm going to put the result of foiling 3x minus 1 and 2x plus 5 in these brackets. Of course, 3x times 2x is 6x squared. Positive 15x and negative 2x is positive 13x. And negative 1 times 5 is negative 5. In the numerator, I have a positive 3x squared and a negative 6x squared. I have a positive 15x and a negative 13x. And if I distribute this negative, I have a positive 5. I now have my derivative, and I want the slope of this function when x equals negative 1. I must evaluate f prime of negative 1. Well, negative 1 squared is positive 1, and negative 3 times positive 1 is negative 3. Plus 2 times negative 1 is negative 2, and then plus 5. In the denominator, I have negative 1 squared, or positive 1, plus 5 times negative 1. Well, 1 minus 5 is negative 4, and negative 4 squared is 16. Negative 3 minus 2 is negative 5, and negative 5 plus 5 is 0. Well, 0 divided by 16 is 0. I now know the slope of my line is 0. Let's see what this looks like if I use point slope form. Y minus my y value of 1 equals a slope of 0 times x minus my x value of negative 1, or x plus 1. Of course, 0 times anything is 0. And if I add 1 to each side, I determine that it's the line y equals 1. Let's take a look at this in our graphing calculator. I'll graph the function f of x. The numerator is 3 minus 1 divided by x. And I'll divide that by the denominator, which is x plus 5. Let's look at its graph. Let's see where this point negative 1 comma 1 is. I'll trace negative 1. And I want to draw a tangent line here. So second, draw a tangent line at the x value of negative 1. Well, this sure looks confusing, but I think we got it right. Y equals 1.875 e negative 7. Of course, e negative 7 means times 10 to the negative 7. If you back this decimal up 7 places, you essentially have a slope of 0. So 0x plus 1.00000. This is 0x plus 1. How frustrating the way the calculator presents it.